Let us start. I'll check if the stream is online.
Yeah. And I need to check out in this Teams thing how to share my screen, I guess.
There's a camera symbol, microphone symbol, and next one is share screen.
Ah, I see. Yes. So, do you see something?
Yes.
All right. I just I need to test something first. Can you see this? The picture?
Yes.
It's coming over. All right.
So well.
So I'm gonna start. I'm gonna talk a little bit about my personal experience in prototyping in arts and as well in making things, manufacturing things. Wait, I'll put down the mask because I'm in university right now and I need to wear the mask when I walk around, but when I sit, then not. So I just fetched myself a coffee and now I can, anyways, to drink it, I have to put it down, yeah. Yeah, nice to meet you, everybody. My name is Friedrich Boell, and I'm a student of Media Arts in Cologne at Media Arts Academy Cologne. And before that, before I did like an arts career, I was working in like technical IT department where I like fixed all the day computers and fixed them software-wise and hardware-wise and diagnosed. I was like diagnosing problems, and I had to do have many interactions with people, and so I was getting interested in the things that were getting thrown away, because when you fix things in like technical jobs, often it means just you replace a broken part with a working part, and then therefore, like, I got really interested in all this electronics stuff, electronic trash that was like starting to float around, and I was taking some home and etc. So I started making things with it, and also in Germany, it's like there's one day in the most cities where everybody throws out some trash that they have. And the street is literally floating with some stuff, and so I collected something here and there, and so I wanted to do something with it, and I worked basically with my hands or with like tools like screwdrivers and maybe like cutting machines or so, but everything was done by hand, and I constructed a little thing which I will show you now. It's also here on this link. I don't know if you can see it. It's a Vimeo link, and it's about a smaller playing machine that was built, and I built it out of parts from a printer. Or this, you can see, this is like a part of a CD-ROM drive. That's the main mechanism of the machine that's used to grab some things. So here's another picture of it. Oh, I really hurt my hand there. Also, that happens if you work with your hand. And yeah, this whole thing was like a playing machine to look like this in the end. So you had like a controller, like they found it also on the street, and you could move around this little thing and grab some candy from there. And I made it out of completely from trash, but I just didn't use any fancy tools or CAD design or whatever. I just built it with what I had, like it was wood and fabric and like some motors, some cables. Some parts came from like printers, which you can see here. That is like the main mechanism to do the XY movement. And yeah, I just tried it out. As you can see here, I just put some metal between, I screwed it, and then if it didn't fit, I drilled another hole, I screwed it again, and I was trying it out really, and Then the parts that didn't look so nice, I was covering them up. So I just, normally if you build something like really experimental and you try here and there and mount something here and there, then there gets lots of holes. So this was the mechanism from the bottom view. And it had like a small spool that could move and that could move up and down. And so, but it was not so visible from the outside. And I used like this metal structure here that you can easily adjust with your hand and then attach some things to it. And it worked out quite well. And it worked surprisingly well. So it still works today, and it had like many hours of, it had seen some parties and some other occasions where it was used. And so here you see it in the middle of a party, and it was like running for, I think now it had run like in a row, maybe 2 or 3 weeks, and it's still running. But I was super surprised that it still runs because it was so so prototypey and so built from the experimentation. And then later on I changed a little bit to that, but that gives like a thought. So everything has to be constructed with like a CAD design. Does everything, maybe sometimes it's way more easy if you want to just quickly try something out, or you need a super quick solution, then you just take a drill and drill a hole instead of like using some super complicated machinery. And I just wanted to show that quickly. Then later, a few years later, like 2 years later, I got into 3D printing and started a little bit with that. And here you see a picture from the workshop where I was then. So I bought this printer. I didn't construct it myself. I just bought it and was using it to experiment and see what it could get. You see the screen here. That's like a custom built screen, and it was also built completely by hand and not without with the use of like complicated machines. I just see if I have another picture of it. Let me see. There, this one, for example, because I found just the wood and when we were cutting it with here, you see the table saw, we were just cutting it by hand. It was way quicker and easier if we had like a CNC'd it or something. And then we just mounted like the panel inside and that's it. Same here. And then, but at the same time, I started to get into like this design and CAD design thing. And I thought about what's the purpose, or when does it really make sense? And so one thing is, of course, when it makes sense for myself to just to learn it, maybe not to achieve something really practical, but just to see how it works. So maybe it's not always like you have to achieve something concrete, but super abstract rather, or try something out. And so I was trying out like 3D printing at that time. And I was like, when you are getting into 3D printing, you also have to get into 3D modeling and 3D designing. And I was doing that by the help of Blender. So I started to learn Blender back then. And it fitted me quite well, I would say, because there's so many resources online where they are aiming to help you to learn something, achieve something in that. And it's super vast program. You can do nearly everything with it. But like for technical stuff, later on I noticed it's maybe not so nice. So where I was living at the place, there was this graffiti on the entrance door, and I walked by it every day, and I decided maybe it's possible to transfer this 2-dimensional shape into like a 3-dimensional one. And that was also, I did this in Blender, and I started like printing out the figurines, the small figurines, and I started to change them a little bit, and then as you can see here. So this was the same shape, like this thing on the wall, but in a 3D printed way. Especially in this one, I used like to smooth the surface, because most of the time the 3D prints, they are not like smooth. So and then I got further and printed it bigger and made different shapes, and that was where Blender fitted me perfectly, because you could super easily adjust like poses, and that, I think that comes from the point that it's like an animation program, so it's meant to do animations, and you could super easily readjust like poses and stuff, and everything was computed again. So or this is the small figurine, this is same size bigger, and yeah, you needed to be very patient for that, because it took so quite long to print something like that. But it was overall, it was like a satisfying experience, because you didn't have to do so much. You designed a piece, you fed it through some software, and then the machine does it nearly all. So it takes some time, but the machine can work by itself. Maybe you just, if you're sure that it's adjusted properly, you just let it run for, I don't know, a day or two. And then you have like a nice thing coming out that's, and you don't need to work so much on it. You could like smooth it or whatever, but the thing was more or less ready. And then I started to construct the figurines also in a different way, like this, like slices. And I think you had in another talk also, you meant there was a slicer for fusion mentioned, and that could also be done with this. And I think it's a little bit more complicated process, because maybe this cutting process goes faster than the 3D printing, but then you need to assemble everything, and that could take a lot of time. And you can get really confused if you're like not sure what part goes where. And so maybe the cutting is a little faster on a laser, but the assembly could get like really, really complicated. And I have another picture here. Yeah. So I was just trying out like different techniques, and by the time I got like the high school here, also they bought a laser cutter, and they had another one before. And for me, it was super important that I was able to use the machinery myself, because the one cutter that was here, it was you had to go over a person to use it, and you reach in your designs or whatever, and the person would cut it out, and it could take a day or depending, and then you came back on the next day, picked your parts up, and then maybe you noticed that they didn't fit, and then you had to go over the whole process again, and that was really not like not working out good for me. And so I found the experience to use the cutter yourself super important. And I'm not sure, I think in your high school they also bought a cutter right now, is that correct?
We are using the cutter this week, but
yeah.
we don't. Yeah.
But are the students allowed to use it by themselves?
No. The university doesn't actually own a laser cutter. That's we are borrowing it.
I see. Yeah. So you just have the ability to use it this week, and then it's gone?
No. Well, after that, we'll have to make special arrangements, I guess.
I see. Okay. Yeah. Yeah, that's. I think the devices, they get like really available in every country. So and they get cheaper also. So I think there's some models that are super cheap, but they are not so safe to use. And nah, that's a different thing. But for myself, it was an important experience to use it myself, because if I just would send a design and that I get it one day later and then it doesn't work, so it's super long process. Then I could also 3D print with the 3D printer that's super small at home, and it would be the same speed. So here are like what I'm showing right now are some examples for stacked stuff to achieve like 3-dimensional shapes with the laser. Because normally, yeah, you know, it just cuts out like 2-dimensional shapes. And then that makes it a little more interesting, but compared to the effort that's needed to assemble it and everything, it's worth comparing it to 3D printing, I guess. I also tried the shape to do it by hand, like to make it from clay. And it was also an interesting experience because it's a super simple shape. So it's easy to test out some things, but it broke a little. It had like the thin elements that broke off. Maybe the arm was too thin, it always broke off. And it was the same, you could see also, it's the same, the arm is super long and thin, so it always break off. But I kind of liked it, that it could get damaged easily. And yes, so I continued like with 3D printing, making prototypes. This is like a prototype I did for a job for another artist, was doing a super large installation, and he needed like, I don't know, millions of those balls, literally, not millions, but I think like 4,000 or something. And he had like let them manufacture like in a company that manufactures plastic parts by extrusion molding. But he needed to know the dimensions and everything, and he had the circuit board that you can see here inside. And I milled the circuit board in a milling machine to have the dimensions, like, and we put later the connector. He was a USB connector. I put it, and to see if that worked out, kind of. You see it's like really a prototype, but just to have something in your hands to see how it looks and feels, and maybe use some screws on it and see if it will screw well and work out. And I think that's super important to have some, if you plan installation or whatever, that you have something before to look at, that you can judge, that you can see maybe this is too big, too small. There's like a weak part, like the arm in this figurine that always breaks off. Then you know it, and then you can change it maybe. So I could change the design of the figurine to make the arm thicker or whatever. And so you iterate through, and you see it. Oh, wait a sec, there's somebody waving. Hey. Ja. Ja, weiß ich nicht. Ich habe gerade hier, ich bin gerade in der Dings, ja. Ja. Sorry, I was a small interruption. That was somebody from the workshop who told me some info. Yeah, so that's, you could also do it digitally, so you could just use Blender to model something to get this impression of the scale or whatever. And I will just show another example for where I did basically the same, like constructing something with slices, but that was for a bigger installation, another job I did. And they were too big for the laser. And so most lasers, I think that you have access to, they will be like pretty small in size because like industrial lasers, they are super large often. But like those small, tiny machines that you can set up in a normal environment that is like desktop environment, they are like 40 by 30 centimeters or something. And so I used a milling machine that was a little bit bigger, the one that's behind me, and it can use parts from 1 meter to 70 centimeters. And the task was to do a ball shape and other different shapes. So this was one shape. This was pretty straight. So that was not constructed from slices. It was just the side walls and everything. was one angle here on the bottom that had to be correct, but the rest was just normally straightforward to build. You could also do it really with conventional tools. But then there comes the ball, and I just, here's some part of it, that's the top. And on the outside, it was completely round. Then after this roughing, so it was like the rough shape, it was grinded down by hand, and was some plaster put into it to make it really smooth. So that were like 3 shapes I had to build for another job. And this one, this ball shape, I also machined it like to this round shape from stack slices. So I think that were like 30 or something in the end. And so I milled them all the outer contour to give this perfect ball or round impression. So you can see it here on the milling machine. And yeah, that was, so I sliced it also using Slicer for Fusion. That was, but at that time I think it was a standalone program. It was not related to Fusion. It was just called Slicer or something from Autodesk. And that's next point. Like I really love Blender, but it cannot do everything. So you need like a construction program. Fusion is like a construction program that's for free, but it's like cloud-based. And I think that's really good if you have different alternatives like FreeCAD, for example, or if you go into learning a new program that could be worth considering, because maybe something changes, suddenly it costs money, or they take away some functions, like they did with Slicer. Slicer suddenly was gone, then it was just available as Slicer for Fusion, and that's like the company politics. So you're really relying on that. Yeah, that was another construction. Then while I continue going into this 3D printing stuff, can show some other daily parts. So there was like a broken wheel, and just reprinted it. And there was a bit tricky part because it has a round shape here, and to hit it right, it was not easy to measure. I just sliced small pieces from this wheel and just printed out small slices and hold them against the part and see if it fits. And I did it twice or 3 times, then I got the shape correct, and then I printed the full thing, and in the end it really fitted well. And yeah, because I was going to I was so annoyed. I was going to construction market, and they wanted like $20 for this shitty wheel, and I said, well, I can do that myself. And yes, that is like, I really speeded up the designing process by just taking slices and printing them, but I think that's also quite a normal process. Here is another part that got broken, and this one and the wheel, I drawed it with Fusion, and was like super easily to adjust some curves and some things in the model after I draw it. And if I would have used Blender, it would maybe get a little trickier to adjust some parts after you just created them, because it's not so easy to go back and edit things. And also the scale is sometimes a little off, or there is no scale at all, or that's there is some scale inside Blender, but if you export, then it's gets messed up. So here's some other logo I did and 3D printed it. And also here I originally designed it for laser cutting, and I had to take care that there were no loose elements that could fall out. And inside some fonts, it's always a problem that if you use fonts and you have like O or some other letters, that then some stuff falls out. So any questions so far? Is the sound okay? Is everything understandable?
I can hear you very well, and I think we can also see you very well.
Ah, okay, because I cannot see myself.
No, we don't see you. I think your camera is off, but we see the presentation very well.
Really? Yeah, I was wondering. So because I don't have a camera image, if this is normal or. But I just carry on. It's not.
Okay.
Not so important. Yeah, then I was getting more into this 3D printing thing. Here's another thing where you made a mold. I had like this thing that was from rubber, and I could not get a replacement. Then I made a mold, and I used like some silicone to fill in the mold, and then I had I could just remove it and had the same part. And it worked also quite well. Yeah, just some examples how to maybe do some stuff in daily life. Yes, and then what else have I got? Now maybe we come to some combinations. Or yeah. Then I was doing a project where I had like a printer printing out stuff. It was a video stream that was filmed from the power plant. So I filmed the steam that was coming from the chimneys and printed it out on like a thermal printer that was also used in the supermarket. And but I wanted to have the paper coming from the top, and so yeah, I had to construct like a mechanism that that feeds the paper, and that's here. And then at first I just used like I made it completely from 3D printed parts here, those side parts that are 3D printed parts, but I changed the design very often because the paper was not feeding through correctly. I was trying out different things here with the distances from the wheels. These are like from bicycle tires, the rubber. And it was going so slow that I decided to, and that was in the beginning of the Corona time, I think. So it was hard for me to get to the laser cutter. So I just used the 3D printer because it was at my home and I just could use it. But I was wishing so bad that I could like use the cutter. It would be so much faster for side parts. And if I decided to move this a little up or down or whatever, then it would be a matter of minutes instead of hours to change, like to make design decisions. And as you can see as well, like it's also made out of like nuts and bolts. And I had access again, and I made some parts from the laser and some other parts from the 3D printer. And I think that's really often a wise decision to do like a combination of both. Because there are some things that are not so easily achievable with a laser cutter, and some other things that are take very long on a 3D printer. So in this part, it's perfect. If for me, it was perfect to just cut this from acrylic and to make the gears from the 3D printer. And that also had the reason because the gears, if you cut them in a laser, it's this cutting edge that is never straight, so it's shifted a little bit, and then the gears won't work so well. They can work well, but then you need to treaten them with a file or something. And so yeah, I used a combination of both technologies to get where I wanted. Wait, I have videos somewhere here which shows how it worked. Yeah, let's see. I think the video in the Teams probably is pretty stuttery, but just to get the idea. Then and so what I was also capable in Fusion, I could like change in the design. I just could grab one of those cylinders here and move it a little back or forth in the design, and everything was copied. So I just could move it around like I would like to, and it copied the holes in this part, and in all the other parts. It was automatically doing it. and that would never have been possible in Blender. I think in FreeCut or other CAD applications, it's quite normal, and that's something I was not so conscious of before. That it could be very important what software to use to make your life way more easy. So here I put some links. Maybe I just in the meantime I just pass them on the chat, and then you can take a look at chats. I cannot go to the chat. Okay, we can go to it later. Yes. Then meanwhile, also I got a little bit into milling stuff, and I must say it's a huge difference to laser cutting as well, because there's some benefits and some drawbacks. Like in the laser, it can cut like parts that are that are sharp. Like you can cut out a square out of the middle of a piece. That's not possible with milling, because the milling tips, they are always round. So you in the corners, in the inner corners of some parts, you always are have some round stick stuff. But the whole cut in the milling part normally is like straight and not angled. In the laser cut part, that's some benefit, and you could use like for sure other materials like aluminium and maybe wood, thicker wood. Like in the laser cutter, I guess like 6 millimeters or something. Then it gets harsh. In milling, here you see it's like 4 centimeters, and that blasted through like a breeze. That was no problem because the mill is like constructed for aluminium. If you mill like wood, it's super convenient. And there I made an enclosure for some electronic project, and it was just made from one piece of wood. So you could for sure do that same thing with the laser cut part, but then you need to glue like many together, and yeah, you would be able to achieve the same. But I also milled like aluminium, or started to get into that, and that's not possible with a laser. And even with milling is so more complicated than this was the part that I made there in the other picture. It's so more convenient, because in the laser you just set like power and speed, and that's it. Maybe resolution, but I never used that so much. And in the milling, you choose a tool, you set the feed, you set like spindle speed, and you set lots of parameters and strategies, and really affects the part that you make. So it's much more complicated. Yeah. Where was I? Then after getting into milling, I was getting into robotics, and that's a whole different story. Latest this year, I used this machine. There was also another job for an artist from Colombia, and he wanted to do a performance with this robot. It's a KUKA. It's capable. Here in the picture, you see they have also a milling head attached to it. So they used it to mill like large parts out of wood. So the reach of this thing is 2.60 meters. So you could mill like parts that are, I would say, 2 meters long or something. It's quite okay, and it could lift like 200 kilograms. So yeah, it's quite a beast. And yeah, that's the robot with with another tool head. So we just put the mask on and made it a little dance. And that's, yeah, the programming of the thing is a little bit also more complicated than programming a mill or something else. But before that, before using this big robot, I was using a smaller one, and to do also 3D prints and to print parts from clay. And that was more or less a part that took place here in the university. So here I just show you a video. I hope it's not too stuttery.
No, it plays very well.
Okay, fine. So here you see some printing process, and it's carried out using a small personal robot. And that robot is so small you can easily use it in the office space, and it's also safe to operate. The other one, the big one's not, so it will not. It doesn't care if there's something in the way or not. So it's really, you need to take some precautions. But this one will just stop moving when it hits something, and there, yeah. So it was smaller scale thing. Wait, now I have children knocking on my window. I just gotta get rid of them. Wait a sec. Let me just wash the lid. Hey, ich kann nicht. Ich muss hier gerade arbeiten. Tut mir leid. So, and in this particular printing process, it was like an experiment because to achieve something like this with a normal 3D printer would be quite complicated, because it would be this paper walls would get in the way of the print head, and it would move it all over. So there was some kind of experiment here, and but it was really complicated to program the arm to have it make the things that we wanted, because the software for normal 3D print is quite well developed. You just fire in some model that you want to print out, and it does it. And with the robot, it's not like that. You need to write some patch to take some geometry and translate it into this path. And I think not so many people use it, so that's why it's not so well developed. We used like Grasshopper and Rhino. That's like another CAD modeling suite to achieve this. And there are like some pieces of code and snippets inside Grasshopper. That's like a parametric tool to do some 3D modeling and programming tasks. And it's like a bit comparable to Sverchok and Blender. That's more or less the same, I guess, in some basic functions. Yeah, and we use this for programming the 3D printing process for the robot. But that turned out that this robot was quite imprecise, so it had a strong wobble in it, and therefore we could not use it so well, because it was bouncing up and down. Here you see it also a little bit that is jittery, and that's especially with printing processes also. That's like really, it's not the last thing that you want is that it wobbles, because then you will see directly in the piece. So I mounted the printing system that's here used with the robot. I mounted it on a normal 3D printing geometry and did some tests, and it worked after some tuning quite well. So I did some pieces in this is like porcelain stuff. Yeah, and like all the 3D printing stuff is pretty much open source. You can just grab some 3D models to see how they construct a printer, and also the software, so I could really tweak some software parameters. And in fact, what you see here is like the software parameters, they are totally wrong. So it's because it extruded too much or too less, so it got messy, but it looks kind of beautiful, I think. And I did a lot of tests with the material, and it is quite hard to handle, because it's not like thermoplastics that get hard immediately when they cool down, because this needs to dry out, and then afterwards you need to burn it. And if it burns, you burn it in a kiln, it also can get cracks or go to dust, because some tensions inside the models. Yeah, but so I did some experiments, and some trials, and that was also interesting because it was like combination of hardware and software, because you could tweak so many parameters also in 3D printing that really could affect the quality of the thing that you are making. I think with laser cutting is also the same. If you have the wrong parameters, everything gets burned, or it doesn't cut quite well, or so. But compared, I think, to 3D printing or milling, laser cutting is quite straightforward. You if it's wrong, you'll immediately notice, and then it won't cut through or something. And so it's quite easy to adjust maybe for the right parameters. And in 3D printing, there's so many software parameters you cannot really tell if it's wrong or right, because sometimes you don't know if it's like a physical problem or is it another problem in a software. Is there an update from your slicing software that kills something? And then after some experimentation and tweaking, I was really able to produce this Benchy. And the Benchy is like a test object for 3D printers to test their capability. And if this would be plastics, you would say, oh man, there's something wrong with the printer. It really prints not good, but it's not plastic, like it's clay. And I think for that, it's quite okay. Because clay is also super difficult with overhangs. Yeah. All right, what else? Yeah.
I have a question.
Yes.
Did you try using different types of clay, or just how did you use this clay? How did you choose it?
It was we have some person working at university who has like a background in ceramics, and she suggested like using porcelain because it's of the structure. And on the other hand, they are like, I know it because I had to do some more with like pottery and clay stuff. It's a quite complicated field. There are like many mixtures, and there could be so many ingredients. There's like paper clay that's mixed paper and clay and so on. It could really give another benefit to that, but I did not really. I wanted always to try out different mixtures, but I didn't have the time, and then somehow the printer broke down, and then I didn't fix it, and then other projects were coming along, and you know how it goes. So it would be really interesting to try different stuff. I think there's some stuff that has tiny grains inside it, like corns or like super tiny stones. And that is maybe not so good to use it in the printhead because it might get the printhead stuck. But it is like pure material that doesn't have like bigger particles, then would be totally worth a try.
Thank you.
Yeah. And also the printer, like I worked a bit on the printer, and I just constructed it to the point that it was usable. And then I immediately went off and used it. And then I didn't care for some weaknesses of the printer itself. I just wanted to use it, and then it broke down. And I was also having like a students exchange program, so I wasn't here for half a year. And then I lost track of it somehow. But later, when the camera is back on, I'll show you where I am with that right now, because I'm also rebuilding it right now. And then, I did another project with some electronic trash, because I found some like this, a box on the street, and it was full of broken phones and displays. And I started to work on that and to sort it out and to see what was it consisting of. And as it turned out, it were mostly like Apple iPhone screens. So I just sorted them somehow and analyzed them, how they work and so. And yeah, I was able to get some light out of them, to let them emit some light, as you can see here. Because they have like the backlight integrated. And so, yeah, I made like prototype where I did like put some in a row, like I said 4 x 3, and I made a circuit to control them. Also tested it in this version. Here you can see it on the workbench. First. Oh no, this is a bigger one. Wait, Then afterwards, when I tried this, I knew it would work somehow. Then I constructed bigger panels like this, but with more screens. And I also milled like circuit boards. Here you can see it, and that's like later on I let them made professionally. So I just first I tried it out with the DIY version of the boards, and then I knew okay that it would work like somehow, and then I would let them professionally manufacture because they were somehow unreliable. They had some shorts or some bad connections. I'm not sure, and it was not so protected. I could also have made a case, but the connections, they were really bad. They were just pins that were sticking out. So I had lots of trouble with that and had it made professionally. But when I was building this bigger panels, as you can see here, I had trouble that there were so many cables floating around them, and it's kind of hard to give it a little structure, and that was where the laser cutter came quite handy, because I used to make a sorting system, or what you can I don't know the English word what you use for your hair also to
A column?
yeah, a column. Yeah, so I made this for the cables and put numbers, so I knew which cable was going to which phone. And then I could just, because I had to put them here on a connector, and the connector was going to the circuit board I showed earlier, and then I could do some, yeah, to get it to work like this. And I made a bigger installation out of it, and yeah. But also here, most of the work was done by hand, and not so much by machinery. It was like a combination of handwork and machine work, I think. And also, maybe it's not possible to have everything built from a company or from something professional in thousands of times. Sometimes also you can just you're in the process of developing something and then exhibiting it, and then it's getting it's working out somehow. Yeah, and then I was working with like plotting machines and drawing machines and stuff like that. And there I would like suggest like taking a short break soon, because I also need to went off for 5 minutes, and then I will tell about a little bit about softwares for drawing machines and how they can be incorporated into laser stuff. What else? Yeah.
So we are taking a break?
Yeah, that would be nice. I could show some other videos. This is like the robot video stuff. But yeah, basically that was the first part of inputs where I would just show some my really personal experience in building stuff and prototyping stuff. I think I left many things out, but let me look through. No. Okay, no. Now, yeah, I would suggest taking a short break, maybe until like 5 minutes. Till then it's 5 minutes before 6 in Latvia, I think. Or?
Okay, so 5-minute break.
Yes, and I'll see how I can end the presentation. I'm not sure. There is it. No. Now my camera works again. I see. Okay. I had some trouble with the camera. Was going away. Okay.
Well,
Because-
we have a suggestion. You can also use a Windows 10 camera, and then we can see you also.
Yeah, I just got an external one. Wait. This is the one. Yeah, because I have some stuff on the desk that I want to show, and so I got the external camera, and it's way easier to show some stuff with it. Yeah. Yeah. But I'm heading off for like 5 minutes, and then see you soon. See you in 5 minutes.
Yes. Well, if you're ready, we can start again. You should turn on your microphone.
Sorry, no, yes. Yeah,
Yes,
thanks for the
thank you.
advice. Yes, yes. So, yeah, I had a short break and some people were showing around here and some children on the window again I had to get rid of. And now, yes, what have I learned most of them? I'll show them to you. Those tiny. I don't know. Here's like they have a children's place and they're like so noisy outside all the time. It's quite funny. So yeah, what have I learned about the machining stuff and so on? I would say like the machines are not so precise. You need to take that into account. You have some tolerances and some designs that work better and some that work maybe not so good. And depending also on the material, especially with 3D printing, you have like different materials to choose from, and you also need to adjust your design for that. And you also maybe wait, they are knocking on the window. That they are you maybe how you design a part, then it's better printable or worse printable, or it's more complicated to print because it needs some support structures. And for example, I have some part here that's quite big, and as you can see, it has like this cut out part here, and then it needs some support here, some support structure. That's from a fellow student. A part he built like a machine with it, or is building a machine. That's some part he will not use because I think it has something is wrong with it. I'm not sure, but also like stability wise, it's super important to take some things into account. Maybe not to have sharp corners on objects. So do you make it round, or if you have like overhangs that are here, if somehow possible, you can maybe not make it so much in the air, so maybe you have like roundings that go to there, that lead to there. That's one thing. And also for 3D printing, and same with laser cutting, I think you already were talking about that the cutter, the laser, it takes some material away, so you need to compensate for that. And the best thing is if you know exactly how much is it. So if you can measure it, like the cut, how much is it, and then you make some parts smaller and some others bigger, and then it fits perfectly. So that's something that's really hard to do if you're not directly on the machine, because yeah, you have to iterate through designs sometime until you get it. Yeah, also with 3D printing, it's the same. Like objects are a little bit smaller than you designed them. So if you draw like a hole that's 3 millimeters in diameter, the 3D printer will put it out in 2.7 or so. So then you can take a drilling machine, just drill it to 3, or you draw it in 3.3, and then it will be 3 exactly. But you need to print several parts to find it out, and that's also maybe you have to throw away some stuff that's a bit annoying. Also for the laser cut stuff, I think it's really good or in general, if you construct something, if you get yourself some selection of screws that you have like different sizes and lengths of screws, and they are like cheaply available normally, and then you know what you will be using, and you have different lengths to try out. And for example, in acrylic, I have some part here. It's a small test part, and I just put a screw inside, and I don't know, can you see it? I think so, or maybe it's better with my laptop camera. I switch here, I think it's more sharp. So I just took like a thing here, a thread cutter, and made the hole a little bit smaller than it should be, and I just cut in a thread. You can just you can also use it without a thread cutter, just by screwing the screw inside directly inside the acrylic, and it will cut itself. But then you need to make a hole a little bit bigger. And there are some tables that you can. I also noted them down in this. I have this sticker site where I noted some stuff, and but I cannot access the chat. Is it blocked somehow? There. Put some info like on threadings and how to there is, but you can easily Google it as well, like to see which hole diameter you need to incorporate. Yeah, and but you can also glue some stuff, or you can make it like this special term is Snug Fit. That is, so you incorporate the curve and the so the part that the laser will take away, you can just put it together and will hold by itself because it's so tight. But you can also, I'll fetch something which I'm working on. So this here is like the frame I'm working on. It's like made out of these construction profiles. You can also, like 3D printers are often made out of them and so on. And I made an inlay from them from acrylic. And so I constructed this structure that goes inside. And I'll take it out. The frame gives additional stability to it. But it will also hold by itself because all the corners, they are interlocked. And so each corner interlocks into two other parts. And then I can just twist it, turn it, and it won't fall out. Yes. So there's also some other stuff. When working with the laser, I really like to work with or to try out some stuff with paper or with cardboard because it's freely available. But another thing, if you like have a laser cutter or operate it longer, especially if there are some students around, like we have here, like everybody comes with some stuff, and you can see in the corner, yeah, that's all material that's like spare. So people use some parts of it, some others don't, and then we have like a whole corner of stuff, so of acrylic and wood and so on. And so it's really tons. So at first I was so convinced of like paper. Paper is for free, but if you look like in the right place, then acrylic is also for free. Maybe you can find also a company that they use with acrylic, and sometimes they have also cut stuff. They cut so many stuff sometimes, and they just have something left over. Yes. Yes, and so here I have some other parts here in MDF to give some hints about design and to make it flexible. You can just cut out some slits from the MDF, and it will really twist and turn. And I got this is like you can just I wanted to show you how to make like 3-dimensional structures out of a 2-dimensional that you just cut out. Another possibility is if you use like combinations like of 3D print and acrylics, you can just make like small angles where you just stick in some stuff. Or you use like folding techniques, like origami wise. So I got like here this paperboard, and this also a design that's quite popular. I think it's also on Thingiverse, and so it's just it consists of slits, but they leave like some parts connected, and so you can just pull them out. And let's It's a really nice design because it's just two-dimensional cut, but you extrude it by a manual process to have a three-dimensional shape. Yes. And for that, I think best is to use like features in Illustrator or in Inkscape. There are some features that adjust some curves to each other. So you can just draw two curves and then it will draw curves in between. And then suddenly you have many, many slits in your material if you cut them. And then the material gets flexible. And that's something really worth trying out. Yeah, I would suggest that is really worth it, giving it a shot. Software-wise, I would like to go a bit about some tricks because you know, like the laser, it cannot just cut; it can also engrave. I think you learned it right now, and the engraving process is normally carried out by the firmware of the machine. So you just set a value. You can just go shoot at it. I don't know. It depends on the system maybe, but normally you can just go with pixel graphics, or if you have filled vector shapes, it takes the fill in and engraves it. Or you can just say get a pixel image and it just will halftone raster it and engrave it. And so halftoning is like a technique. I think most of you will know what it is. It's like it replaces certain colors with tiny dots. And so you can also do that manually, which there's a script I would like to show now. And it's developed for drawing machines because when you have a pencil and a pencil just can make a dot or make a line, and it cannot make a grayscale line. So to achieve like grayscale image, you need to do some tricks. So maybe you go like this over the paper, or you replace like many tiny lines to achieve effect. So I'm gonna wait. How do I share? Where's the share? There's the share. This one to share. So now you should see the screen again. This one program is called Stippelgen. I also noted it here, and it's from a guy who does like drawing machines. So name is Evil Mad Scientist, and it really makes a point. And so it's intended for drawing machines to represent pictures with small tiny dots. So, and why is it, or could that be helpful in lasers? And the answer is just maybe if you want a picture on a surface, then you can just engrave it with a laser. Maybe if your laser is quite powerful, you can engrave it so that the material gets shined through. But another way for achieving like projection effects is like cutting small holes into the material. That could be achieved with this if you transfer image into a halftone pattern of these tiny dots, and then you can just engrave or cut them because it will be vectors afterwards, and then you cut many tiny holes inside material, and then if you shine some light through, you can get like a projection effect. I just want to go over the program and just show it briefly, and it's written in processing. I think most of you will know that it's like a Java-based programming language, and so I had a compiled version here because in processing sometimes it's important what version was used. So here we have the basic script. You can just put in some image. So it calculates. So I will just enter the picture that was my self-portrait that was used also to announce the talk. And now I crank up the number of points. And you can also invert it here, definitely inverted version. But the program takes some time to calculate. And that's why what you see here is like a so-called Voronoi pattern. And that's, if you Google it, it's about the mathematical model of cells, I think. So to model growth, some mathematician issued it. So yeah, it's basically this StippleGen software utilizes this to make a representation of the image, to build some cells of bright and dark areas, and then put some spots inside, and then the spots will make up the image. So it's still rendering. And now I can just hit the pause button here. The fan is turning on in my laptop now. So I can just adjust for the size of the points to optimize it a little. And what it also does is it creates a so-called TSP path, and that's the traveling salesman problem. That's so it takes all the points and tries to make a path that goes through all of these points, but in the shortest order. And you could also use that TSP path to cut out. And that's like the one-line representation of the image. And it could also get some nice effects. You could just cut that out with the laser cutter and see what will happen. It's worth a try, I guess I would suggest. And then let me see. So now in this program, you can now export the stipple file, also these dots. Maybe I show you the original image. I think it's, I should have let it a little bit longer calculate. Then so this is the image. Maybe I also can crank up the points and have a little cut off on the right.
Excuse me, and you said this program is called Evil Mad Scientist. Is that the one?
That's the author, the guy who wrote it, but it's called StippleGen.
Okay, thank you.
Yeah, I think it definitely was taking a look at it. I must admit I didn't prepare the image so well, so I think it's good if you have like a really white background, strong contrast, etc. So I just cropped this out, normal photo. So I think it's a good idea if you really want to use it to prepare the photo. Maybe use Photoshop to just cut out the head to have a white background. It will work way better, because otherwise there will be so many points in the background that the effect is, it's not so clearly visible then.
And the aim of this is purely decorative.
This is purely decorative. Yeah. This is, but you can use it for projecting images. Like if you want to do something with a laser cutter that's used for projection, or maybe you want to put something in front of a candle, or you're doing some candle stuff, then it could be really a question how to get like a picture to in a projection. And you can use this for that. So, or you can use this for getting like TSP images, and this is for example TSP image. Like it represents the image in one line, and it's also a cool effect. Often with laser cutting, there's the problem. If you cut some stuff, then it will look good as an image, but if you cut it, everything will fall apart because there are no structures holding some stuff, and then it won't, yeah, like your image disassembles. And in theory, if you use it with the TSP path, everything in the white is connected because you see here, it's one path. Everything is connected. It still will be very fragile. I haven't tried out cutting with a laser density like this, but I've cut other stuff. For example, I'll show you this. I was once in a design store and they had like a picture like this on the wall. I think it was super expensive. There was like a super fancy store. They had like lamps for, I don't know, thousands of euro. I just wonder who can afford those. But they had like a picture on this. And this is foam. The picture was composed out of foam. They cut some foam and to have to represent the image. So again, something purely decorative, yes. And I had a closer look. So it's also like encoding the image in the depth of the foam. You could do something with this, like with a laser. And there's another program for this. So here, now here you see the picture is the same, but now it's encoded in the wavelengths of the vector path. And if you would cut it, you will have. You can also use this for projection or for what else? I'm not sure. I think it's definitely worth giving it a shot. And this one is called Squiggle Draw. It's also like a processing script to do something like this. Squiggle Draw. You'll find it on GitHub, but for this one you also need processing. I think you need to use version 2. Otherwise, you need to change something in the code, but it's not so difficult. And so I'll just show you this. So same, you just load the image and you can set some parameters to how many lines is like important, because if you use maybe like 30 or 40, it's doable in some time, but if you use like hundreds, laser will take forever to do it. And maybe not to let the lines overlap, so you can set the strengths here. Some details, so you can really go down, make it abstract. And because the lines start here and end here, nothing will fall out of your cut of the part that you will cut, because they will still hold together. I feel that's always like important to how to achieve that the laser cut part will not fall into its single elements. So another thing that I just wanted to show is a program called Pepakura. It's wait here, this one. This commercial program costs some money, but I think you can use it without buying a license. Test it a little, and it can unfold 3D objects into two-dimensional folding plans, and with that you can just cut them out and assemble them. So it's also a method for like constructing stuff I'll just get the 3D model to load. I must admit that if the model is too complicated, it will get really messy. But I've done it with this. I'll show you this one. Let's just load it. So I made a mask like this. I just saw it on the internet and then I designed myself quite similar one. And this one I just fired it up into Pepakura, and then I was taking a video projector, projecting the cutting plans to the wall. I was sticking some paper to the wall, cutting it out manually, and just gluing it together with lots of hot glue, and worked quite well. But now I'll show. So this is the object. Should not flip it. Front is there. So done. You enter the dimensions. This is a bit small. I think it's missing 0. So here I just scale it up. That makes more sense now. So, and then you can say unfold. And now you have like origami style cutting plans. I must admit that Slicer for Fusion can do something similar, but somehow I like this more because you can specify which where it should open and close the foldings. So I can say that it should. You can also edit the position of the flaps, so where it gives you lots of options how to adjust the thing. And I'll just have to load it up. Slicer for Fusion to do the same with this. I think you had it was mentioned before here in the series. So I'll just nagging me about the Fusion 360 website. So wait a sec. So it didn't. It crashed. So the Slicer for Fusion just crashed on opening this thing. Yes. And now I think here it's also possible to print it to PDF, and then the PDF will contain the vector data and so on, and you can transfer it to the laser. Also, maybe you can scale it up or down. And the thing about this is, you can see here, it has valley and mountain folds. So there are some parts that need to be folded in the one direction, others in the other. So normally, if you would do it manually, you just flip it around. But it's kind of hard to put it in the exact same spot in the laser where you cut it and have it cut from the other side. You need to make some kind of tool for that. I think that goes too far, so you just engrave maybe all folds from one direction, from one side. And if you engrave them really with low power settings in the laser, it will be a breeze to fold. So then some other stuff about this things. I don't know if you know it. The useless machine. Does somebody know it?
Yes, yes, of course.
Yes, yes, of course. It's for I think Shannon and another guy, like they were like scientists. They invented this thing. I think it's a nice small project to do if you have a laser floating around and trying out things. Then because basically it's a box and that has a lid, and the lid closes itself, opens and flips a switch and then closes again. So just in case somebody doesn't know. And there are tons of this on YouTube about like advanced versions. This one, for example, has tons of switches, and it's like really this is a bit more hard to construct, I think, but the basic version just has one switch, and when you switch the switch, the machine opens the lid and switches it back. And that's a nice little project if you are looking for something nice and easy to build. But you need to get some batteries and motor. Yes, so will be not completely analog. And also another thing is this endless machines. There's one called machine with concrete from American artist, and that could also be nice to build with a laser cutter, something similar. It's basically just gears. Also, laser cut is not perfect for making gears. Could work because here's a motor, just turns gears, and they shift it in the ratios to get slower and slower and slower. And so in the end of the machine, the gears will not turn. And this artist had put them into a block of concrete. So that will be also a nice project to make. Maybe also not so complicated, but again, you will just need a motor. And so in this installation, you see it takes 13.7 billion years to turn the last one. And if you're going easy and you're like really tired and don't want to do something yourself, you can just go grab one of the box generators, and you can you don't have to draw the box. If you were looking for making a box with the laser, you can just go to a site like this, and I think there exist different ones, and you can just enter the curve, so what's your machine is taking away, and in the end it will get you some PDF plans to make a box that has the overall dimensions. There's even one service like this available that has a like 3D model of it. Is this one, maybe you also know, and it has different types of boxes to choose from. So even one with a round shape, a round corner, and that's will be that is made by the putting lots of single lines there. I can show you here if I go there and get to drawings. You will see here it puts just many single lines. And so
I'm sorry, we can't see anything.
Ah, yes. No, yeah. So yeah, if you choose this shape, so it's a generator that even has like a 3D small cute 3D model in the browser, and has some different styles of boxes. You can just say it's in inch, so you gotta switch to millimeters. You can also switch, I think there's different languages. For me it's in German, but I can also switch to English. And yeah, you set all the parameters of your material and your stuff, and then you get to the box plans. And then for the round type of box, you see that it in the round corners, it just places many lines. And then you can bend the material there. And I can show you on the camera. But you gotta be careful because sometimes it breaks. And also takes some time if you do it in MDF to cut that many lines. And once I did something like this, but in paper. like in thick cardboard, and it was starting to burn inside the laser. Didn't notice at first, but I noticed quite quickly because I think the cardboard, if you cut it so many times in small space, it gets really hot and then it starts to burn. So after some seconds, I realized it, and then it was already having decent flame there. So I immediately put it out. Like I opened the lid of the laser and like we had some small fire stuff. Like that's, I think it just is without powder. It's just some gas or so, and I could just put it out. But that's like really one reason why you don't leave laser cutter just working by its alone. That is really, sometimes it's not so healthy. And I can also show you, it makes lots of dirt in the cutter. If you cut like many small lines, especially in MDF, or like this one, for example, if you cut like this, it makes many smoke and many dust particles. And we had it once in the laser here that somebody was using it and was not cleaning it up really. It was really stuck full of debris, and this was what the lens looked like. So there was like lots of fumes going up to, and then there was stuck here where the beam would just leave the casing, and then it got burned, all the fumes into the lens somehow. And at first we thought, oh shit, the lens is broken, and then that would be expensive, and also the machine could not operate, and what else. But it turned out that it was just removable, so we were quite lucky. But it was so hard to remove. I remember it was not. I could not use any solvents or anything. Just clean it. It was. I had to scrape it really carefully with some soft wood. And yeah, so if you do something like this, don't leave it unattended and watch closely. And so it really makes a lot of dirt. So that's important, I think, to give the machine a cleaning, nice cleaning sometimes from time to time. If you cut lots of MDF especially. Yeah. And so I can show you. Wait. So, and another possibility, if you have Inkscape, which I would recommend installing anyway, doesn't hurt. It runs on all platforms, like on Linux as well. Then especially, yeah, there was a new version coming out, Inkscape 1. Was felt a bit like Blender 2.8, so this is version 1. But I was so disappointed because there's one extension here that you need. If you would directly send the stuff from Inkscape to the laser, you cannot. In our laser, we need to print here to print, but with Inkscape that doesn't work. You need to print as vector graphics. There's a special thing here to export, and then there's Windows 32 bits vector print service, but that has some bugs in the version 1 of Inkscape. So for me, at least, it does not work to directly send something to the laser from Inkscape. That's really disappointing. I need to go to Illustrator all the time, and it's a bit annoying because before I could just issue like 2 mouse clicks and hit the file in the laser, and now I need to save it, open it in Inkscape, check everything's correct, and so on. You know it. Some other things, some hints I would like to say is if you're doing something with text, there's like a nice thing in Inkscape. If you want to just write something like this, then you'll have like double outlines. And if you have lots of text, I know some projects that had like many text inside. So I'll just kill the filling because I want to cut it out maybe. Let's assume I would just cut it out. Then you see you have double lines. The laser would cut like this, and then it would go twice on the inside, on the outside. You see, it would take a lot of time, especially if you have like lots of text. Or if you have very small text, that could also be the case, it would take you very long time. So there's something that's called Hershey fonts. It would I don't know if you know about this. It's like I think it's a company that made sewing machines or something. Anyways, they made like a special font that's that was meant for machines to manufacture it easier. And you could go here to text, Hershey text, and you don't have the same vast options to choose from like you have in your normal installed fonts. Like I have thousands of fonts installed, and you have just like, I don't know, 20 or so here. But there are all one-line fonts, single-line fonts, so-called. It means they just incorporate one line, at least if it's noted here. So just removed one, and now I have a single-line font. And that really comes in handy if you need to engrave, like, for example, let's say you're making yourself contact cards for the next fancy art fair when Corona is gone, and then you want to impress everybody with your super cool contact cards, and then you need to make thousands of them because you want to be make good contacts with thousands of people. Nobody's holding you back, no Corona stuff, and then you need to engrave thousands of text cards. You would surely consider using this because it really saves a lot of time. So now it's inside of Inkscape in the new version 1. It's comes with it. It's on the text, Hershey text. So, and also Inkscape is capable of doing boxes. So you can just do like a foldable box. It's a bit pity because I have the localized version here. So in German it's called Faltschachtel, but it's foldable box in English. So we just give you a foldable box. It takes some time, I think, but it should be there. Maybe if I zoom out. Oh yeah. I think I have there were some strange parameters in the script. And I think these are just Python scripts that come with Inkscape. And let me go there again. So I set this to millimeters. It's better. I don't know why it produces so strange lines up there. So this is a simple foldable box, but there is another one. I'm guessing it was called laser cut box. I used this one before. Dart generate. No, this is a special thing for some other lasers that need different controlling. I had it in the older version. I have not. Anyways, by the way, you can also generate new like Lindmeyer systems that are like fractal systems, but I wanted to show you the tool to generate the boxes. And it's called laser cut box. But maybe it's not compatible with the new version. We'll take a look. This one. So I used that also before for making boxes. And that's a quite nice one. So if you are on the other hand also looking for designs, you can definitely go to Thingiverse. There are lots of 3D printing stuff, but also some milling and some laser cutting stuff. And So yes. There's also quite nice laser test for setting the power, and you can see it here, like with lots of different patterns and stuff. And it's also just a SVG that you download, and that's getting different. It has different colors inside. You just set them, and then that's it. So right now, I would like to maybe go into a discussion. If you have some questions or some topics to discuss, then that would be nice. See, some people are online here, and so any question?
Do we have questions? Thank you for your speech. I have a traditional question of this week. What do you think is the future of prototyping?
That's a good one. That's a good one. I think it's a good one. It depends. It's sometimes, I know, if you buy a product, then it's often super developed, and you buy it, and then maybe there's something you don't like about it, or you want to change something about it, or you need to enhance it in some way, and then you could just, maybe some companies, they'll just release another product that has some new features or whatever, but maybe something can be incorporated using like these personal fabrication techniques. So maybe you can just there was the example with the panoramic, the camera, where that had the sum in the image. It was a perfect example, I think, for something that you could change by yourself, by like personal manufacturing techniques. And the prototyping itself, it could be achieved in many different ways. I think you don't need so fancy machines to do it. It's also good to have a vast knowledge of what materials do exist. And maybe sometimes, like metal, for example, to know some properties of metal is super handy. If you have some thin steel, you can just bend it, or you can even cut it with the special scissors for steel, and you can just fold it, or do some small angles, or whatever. If you do some small stuff, sometimes it's way more rigid than going for the complicated route with CAD design and printing. But also that I really like the printing stuff, because for me it gives me a professional feeling somehow. If I can draw something, it looks nicely, and it looks like I draw it. If I want to change it, I just redraw it, and then suddenly it's not a prototype anymore, it's a finished product for myself, but it's personal. So I feel it for myself as a finished product. For somebody else, it might be too. Maybe some friends come and say, "Oh, that's so nice what you have there. You have such a nice lampshade, or you have such a nice holder for this and that. Can you also make me one?" And then suddenly it's not maybe a prototype anymore. Or maybe it will be a prototype if, like, let's say you make a light for the bike. Somebody sees it. "Oh, what a nice light for the bike. I also want one." But the person has another bike. It has a different shape, so you need to adjust the shape. Then it will be still a prototype, because you adjust it constantly. But the future, that's hard to say. I cannot say it.
We have questions from YouTube. And do you have any recommendations with €2,000 to €3,000 laser cutters? I'm guessing that they are meant to be the cheap laser cutters.
Yeah, I must admit, because right now I'm really comfortable here at the university. We have like this. I can show you this. Wait, I'll just
this works. This is a system here, universal laser system, and it's also like desktop system, and it's really expensive. I would not be able to buy it myself because, like, I don't know, hell, lots of money. And soon I'll be finished here in the university, so I need to make also a solution for myself to have this cutting. And for 2,000 to 3,000 euro, I think maybe you check for used machines. Sometimes I saw them; they were available for 2,000 to 3,000. Otherwise, like in lasers, mostly you have like European or American companies that do like super expensive machines. That's my feeling, at least. I'm not an expert in the market, but that cost above like or around 10,000. And there are like Chinese machines that cost from 400 starting, or like if you have diode lasers that are like on a cheap 3D printing mechanics, like you can get them maybe for 200, but they are completely unsafe. And I think they are not so precise. So if you really want to use it, you need to put some time into making them better. And for 2,000 to 3,000, I think you can get Chinese lasers as well that have a bigger working area. Like I think they can work around 70 centimeters to 1 meter. At least I saw them on eBay for like 2,000 to 3,000. But it's a bit, I feel it's a bit risky to, like, it's quite a lot of money, and you paid for like this Chinese laser. You don't know how well will it perform. I'm in the same situation. I have to think about if I'll give it a try or not. But I guess there are like these lasers that are called K40. That's the super cheap ones, and they're well documented, and many people are pimping them and making them way better. Then you need to put in some time, okay, and maybe also some money. And then in the end, the cutting area is quite small. So I was also thinking a lot about this, and I was thinking about maybe to construct it completely yourself. You can just buy the laser tube, you can buy the mirrors, you get like construction profiles, like those aluminium ones. And on Open Builds, it's a web page that lists some buildings where people just build their own laser cutters. But you have to know if it's worth your time and everything. So, or maybe just look after some tests that really say something about the quality of the bigger Chinese lasers. I have not seen one myself, but they could be good.
Thank you. You have another question? What is your favorite part of this building prototyping? Why do you do it?
The favorite part is when you have everything and you put it together. So that's really the favorite part. And sometimes I try to work like I use a lot 3D printing, and you need to be very patient, but I try to utilize the time. So I just print something and work on the part that I print. And so I have the first version ready, and then I already, when the first version is printed, I already have the second version maybe, or some additional parts that come to it. And then I can just test and probe and then go over. So if I have some time, I also like the process to draw and to draw and to draw. But the best definitely if you put everything together and then it works out somehow. That's the best. But also with the milling stuff, it's the milling stuff is so complicated. But if you have like metal parts, they have a superior quality, I feel. Like if you have like machined or milled aluminium, it feels quite solid. That's also satisfying, yeah.
Do you have any future projects that you want to work on?
Yes, I have. I work lots with screens, not just the small iPhone screens from the light installation. I also like work with bigger screens and with TV screens and computer monitors, and I disassemble them and build like custom screens out of them. And now, I'm working on that right now. And that's one thing. The other thing is I have both.
I think you know them, and they are definitely worth a look because it's also about like hacking. You know these?
Yes.
Yeah, and you can get them. These are broken. I get them for $10 or so, or $15 from some affiliate. Like they are broken. They sell them on, I don't know, online for super cheap. And if you're in luck, then the battery still works. And there are some other people who wrote a custom firmware for it. And so you have like a really powerful electronic drive, like the wheels. And I think they have 300 watts or something. And you can control them via serial interface or via joystick or whatever. So the balancing function that goes away, but they are go a bit faster because they tweaked it for speed and for torque, and so you can go build crazy vehicles, and I think that's quite some fun. Yeah, well, there's a side project. I'll definitely work on that. That's called Transporter. So that's the name of the coding project. So yeah, it's super ambitious and like so many people working on this, on the coding, and they make it better. I have different controlling types for the motors. That's, yeah, it's a nice, super nice side project.
And what is your main research subject?
Yeah, that's a good question. I would say material, just material. I'm curious about like different materials, like the clay printing, for example. That was a super experience because the material clay is quite well known, but also that's a new technique how to utilize it. There's also I find like biological processes also super interesting. There were like I made some efforts to or there exists something like biological cement that's also worth investigating. That's it's funny because it uses P, and from the P it magnifies the sand, and so it fortifies the sand and makes it to stone. And so that could be a researching project. But I'm not that much of a researcher. I'm more into artistic stuff, I guess. Yeah, and machinery. I really totally like machinery.
Do you have a local community where you all come together and build weird stuff?
Yeah, we have a community here in the university. That's but some students, some of my friends, they degreed, and for me, Corona came just in between. So normally I would just be working on my degree right now, or I had it already, but Corona came and finished it because I was planning to do some machines that you really touch and you interact with or go inside or so, and that's not so easily possible. And yeah, but so the community also Corona-wise, it really is hard to maintain right now. I think in Cologne are many. There's also Fab Lab and so a making community and so on. But I'm not that much into contact. But we are running a cultural center in Bonn. That's a neighbor city. So it's a bit political also, and this it's quite nice. It's a super large building, and there are so many groups coming together, and there were people dancing. You wouldn't believe how many people dance, like it's a sport or I don't, whatever. I never thought of it, but you have like 20 groups of people that come there to dance, and then they just finance all the whole stuff. I don't know. And we have some ateliers there and so on. It's quite nice. Yeah.
And some online communities maybe you're part of?
Yeah, not really. I just browse through the net and so on, but I feel I don't have so much energy and time to invest into the thing. I would love to contribute more. And maybe in some sections of like chip tunes or so, sometimes I go there, or like modules, and so music wise, but I'm not so much like uploading every time. So it's, I feel like real world is really important also. And I work with lots of projects, I don't have so much energy to document everything online or put everything online. Also, my homepage is needs to get a work on and so on, and life's going.
Oh, I understand perfectly. I haven't updated my website, I think, in 5 years. So that's I understand completely.
Yes. But I'm amazed when people do like documentation perfectly online of their project. I like it so much. I'm so grateful for that. I could never do it myself that perfectly, but some people they can. I don't know how, but they do it. Yeah. Hope some of you will.
Yes, I hope so too. But thank you for the conversation.
Yeah, it was a pleasure.
And it seems like we don't have any other questions. We have a seminar tomorrow that starts at 2 local time. So we would be very happy if you would join in. I will send you the link.
Yeah, please.
And let's keep in touch.
Yes.
I would be very happy.
Yes. Yeah, I would love to come over sometime when the Corona stuff is over, and then just.
Yes. Let's just wait for now, and this festival is an annual thing. So let's try again in a year.
Yeah, sounds good.
And thank you.
Yeah,
so you can stop now.
Yes.
And,
I hope I didn't bore you too much.
No. It was very, very informative, very fun. Thank you.
Okay. Well, have a nice evening.
Yes, you too.
Yes, thanks.
Bye.
Goodbye.